Testing. Ooh.
Which mic was that? The one that Warren is dancing with.
All right, let's get that thing going. QR code shit's magic. I know.
I just turned on the.
Oh, okay. Yeah,
Yeah, there you go. Well, here we are. It's nice to see everybody here in the room in real life. Welcome to Philadelphia. And for those remote, we're happy to see you too, wherever you may be. Your chairs are Benno, Tim, and Suzanne. The lovely and talented Tim is in the corner here. Our AD is also here, Warren. The Jabber Room is alive for this time. We're, I guess, moving to Zulip after this meeting. We have Paul Hoffman taking minutes. Thank you, Paul. Next, please. The same old familiar note well. Please read it. Understand it, think about it carefully, because we are held to enforcing that. Next. Also a reminder about the code of conduct, which I think is common sense to everybody here. But these principles we're expected to abide by also. Thank you for your cooperation. It makes everything easier when folks are willing to follow this. Next. And some IETF meeting tips, particularly for hybrid. Some reminders for the in-person participants. Everybody should be signed in to Meet Echo. That's our blue sheets. It's the only one we get now. Meet Echo also manages the mic queue, allows us to manage the mic queue. Keep audio and video off if not using the on-site version, just to keep things simpler. And please, we've been asked to remind everybody, wear a mask unless you're actively speaking at the microphone. Remote folks, we all know how to do this by now, but make sure your audio and video are off unless you're us or presenting. And for those listening in whatever space you might have, a headset makes everything better. Next, please. So we've been through the introductory commentary. We've got a message from our sponsor, RAD, who wants to speak briefly on an initiative he's setting up. We've got the usual updates of work in progress, hackathon results, and working group business discussion of current drafts and possible new work. Yep, so the agenda, this is what's in the slides, is also online. So, and all of the drafts and all of the slides are in the meeting materials repo. So I think this is Warren's turn.
Woohoo, I turned it on. Wow, I fixed it. So actually two things. First off, I've been doing this AD thing for many years now, and I am still enjoying it. But my term is up in March. I probably will run again, but I would like there to be other volunteers, etc., other people willing to serve in the role. So if anybody is interested or considers being interested or even just wants to know more about it, please come along and talk to me, and I'm happy to explain what the role is actually like, what the time investment is, the good bits, the bad bits, etc. So please hunt me down. I'm sort of generally around. I've got a big hat so you can find me. So the actual topic, DNS Directorate. This is something which myself and Eric Fink are organizing. So apparently this DNS thing that we've built is really popular, and now everybody wants to do it. DNS-related topics show up in a bunch of working groups. 25 of them are actual sort of documents, working group documents, 13 in Dnsop, 3 in DNSSD, 3 in ADD. You all can read that. The thing is, there are currently 59 existing drafts that mention DNS somewhere in the name or abstract. So obviously there's a lot of DNS work happening. And also there's a lot of places where people are doing DNS work sort of in other drafts, but they kind of mention DNS and then try and build on it. And that doesn't always end well. Next slide. So, here's a whole list of non-working group documents. As you can see, some of them are aimed at Dnsop, but a surprisingly large number are aimed elsewhere. Next slide. One of the problems is many of these documents don't really get any Dnsop or DNS-focused review until they show up at IESG eval. So recently on the telechat, there was a document which tried to make extensive use of the DNS to do mapping from sort of some type of physical things to who owned the physical thing. And it's not clear that the DNS is the best way to do that. But there hadn't been any review until then by DNS people. And some of that is there's no easy way for people to get DNS review from DNS people. So what we're planning on doing is creating a DNS directorate. There has been one before. There was a DNS directorate many years ago. This is sort of Dns Directorate V2. And it's going to be like most other directorates in the IETF, like Opster and Sector and similar. It's going to be a way where, actually next slide, where documents which are being progressed through the process can have a set of DNS people look at it. So this is, not actually what the actual purpose is, but this is the Opster disclaimer with a little bit of text changed. Basically, some things so that drafts that are progressing can be reviewed by somebody. They get reviewed by a member of the DNS Directorate. The comments are written for the ADs. Document editors and chairs are supposed to treat them like any other comment, but a way to get some focused review on it. We will be asking for volunteers who are willing to serve. It shouldn't be a particularly onerous job. There are not that many documents. And hopefully it will be fun. So as I say, we're going to be looking for at least 2 secretaries and a bunch of volunteers. Please send myself or Eric Fink email, find us, contact us, etc., if you might be willing to serve. We might also do something where for some of the drafts, we try and get both an experienced Dnsop person and somebody sort of newer to the IETF to both review, so people can get some experience, learn some more, etc. Are we taking 1 or 2 questions? Or if there are 1 or 2 really short questions, happy to take them, but I think it's relatively self-explanatory. Folk who are willing to review stuff. Great.
And we've got some updates, and Tim is the guy that wrangles the list of what's and where. So
Thanks. I don't have Warren's knees, so I'm going to actually probably just stand up here and do this. So unless I can borrow your knees, Warren. The reason this sort of came up with the document up the DNS Directorate is because I usually do that search before every IETF, looking for some like, whoa, that's a crazy document sort of thing. We better sort of think about that. So, but we're kind of good on this idea hopefully sort of keep tabs on stuff. So let's do some document updates. So since our last meeting, Nsec 3, well, it's actually North 48, and Victor and Wes are busy sort of wrangling the editors, and I think they've come to some consensus on that. Victor? Yep, I saw that this morning. So we've got 9276. Service B is, and they've been in the editor queue, mostly because of the ENSI document. But there has been some changes, and Martin Hoffman suggested some A, B, and F changes recently that are in the repo. And I think we should may want to sort of bring that to the list just to make sure nobody has any issues about that. But that thing's been sitting for a while, and people have been still commenting on it in the repo, just trying to understand the basic things, which is good. And I figure let's do that now before it hits the editors, and then it all sort of goes sideways. So thanks, authors on Service B. And as you've noticed, there's lots of Service B documents in the IETF now. So it's not just become an R type, it's become like an R type that everybody wants to use to solve everybody else's problems. So that's for good, better, or for worse. So next slide, sir. So I threw this in this morning, the 5933 biz, I'm gonna have to do this. Dimitri submitted a new version this morning, and I think we need to review it. There was a comment that came up about switching it to informational, which actually they've done. So I think Mr. Hoffman, who sort of made that, I think that has been sort of addressed very well. And I believe they've addressed, I'm going to go through it, all of Mr. St. John's comments as well. So we need to review that, but it came in sort of right off the bat this morning. In working group last call, we have avoid fragmentation. We put a 3-week call on that because of the meeting in August and stuff. And so we'd like people to sort of review it and give us some feedback. We think it's in good shape, and we hope everybody else does. So next slide. You're going to be busy for a while. So some upcoming working group last calls, and you'll see this from Paul. We believe the Dnsec BCP is ready to go, and we'll probably fire that off this week as well, probably with a 3-week working group last call. The glue is optional. Again, this one's done. And so the only question I have with the working group is, do we start it now? Do we start it in September? The chairs, we always kind of sort of feel August is where the civilized people take holidays. And so, which that's usually Europe. And things get a little slower, and we respect that. And our question is, do we fire everything up in September, or so do we let this run through August, through now as well? So if anybody's got opinions on that, please speak up. Like to hear it. So next slide. But wait, there's more. So catalog zones is done, but the authors are all actually on vacation right now. So we're gonna start that working group last call early September. So get ready to be busy. And also validator requirements. Daniel's going to speak, but we kind of feel it's been through the process enough. It's ready for that too. That's another one will be in September. So you guys are going to be busy reviewing documents, and we're going to sort of be chasing people down. Next slide. What do we have here? Oh, so Ns3 Validation, we've been sort of being patient with the authors on this because they've been busy. And there are a few outstanding items. And Schumann's assured us he's getting some assistance to finish these items so we can sort of move on with it. So that's a great thing. And we've hoped on that. So, and then 8499 biz, which is another one that's kind of been stuck a little bit. What we want to do is have an interim to finalize that bailiwick definition. And the interim is the right way to do that. It really can sort of focus the conversation. And so we have two choices, one's before the ICANN, the other one's after, and we'll probably send out a doodle poll to figure that out. And maybe after is better. We'll let people decide on that. Next slide. What do we have? Oh, error reporting. The authors are on holiday as well right now. They got back to us, but there is some stuff happening, and we're waiting. They're going to get back to us next week when they're back from vacation to tell us, give us more feedback on that. We don't know about zone version other than the latest updates, so we need to sort of talk to the authors about that. They've created an Dns registry, which I want to sort of read more about and sort of understand what they're doing there. So the Dnsec automation, they need to add another author from the .sc folks. And but Johan's implemented the entire protocol. So that's kind of a bonus. We always like to see that. I know Peter submitted a new version of Dnsec bootstrapping, and it's been sort of moving along. So we think that's in good shape. So we're pretty happy. Next slide. What else do we have going on? Oh yes, we adopted 2 documents yesterday. The domain verification techniques and the caching resolution failures. They've got enough sort of comments. But the service B Dane document, which did very well in that Warren poll that we did, didn't get a lot of comments. So I'm hoping some people can walk up here and take the microphone and sort of speak, yes, we should adopt this sort of thing. So hopefully there's somebody in the room, because we feel that there is interest in it, but we're surprised by the lack of sort of email comments about it. So yes, yes, no, no. Okay. Or just send email about it, please. Because we're kind of confused by that one. Because we got a lot of positive feedback, but then we didn't get a lot of email about in the call for adoption. So someone can help us sort of understand that. That would be great. Next slide. Okay, yep, our stuff's in the data tracker, and we're also in GitHub in the usual places. We keep data tracker very up to date in terms of everything, including, repos for where documents are and stuff like that. So we try to be pretty much on top of that, which makes our AD very happy. So yay. And I think that's it on the document updates. Anybody's got any things to say? I know there is things to say about the poll and stuff, but I think we worked through all that. But we're willing to sort of take any and all complaints. So, and I'll put my cane down so I won't beat you when you start complaining. So, comments? No? We're cool? So, and I think the next thing then is Hackathon updates? Yep. So I think this is Peter. Peter?
Thank you so much. Niels? Oh, Niels, you can also stand up here. Yeah. Thank you. Hi, everyone. I'm Niels from Dnsec, and the hackathon update from our side is we implemented, I can actually look here. We implemented Dnsec bootstrapping in 2 fashions. The first one is a periodic cron job implemented using DNS Python, I believe. Thank you, John O'Brien. And it sort of scraps the CDS and CDNS key records from a trusted source and generates the signaling zone, and then pushes it out to an appropriate place. So it can be then read from the actual signaling domain. And the other part is work from Peter and Jerry and myself. We implemented the signaling zone in PowerDNS using their Lua records. So in that implementation, everything is generated, synthesized on the fly. When you ask the query, it also connects to a trusted source, obtains the records, signs it, and delivers it to you. And both implementations are actually deployed, and I think the links are on the slides. Thank you.
Thank you.
Taking questions for this? Yeah. So there are immediate questions. You can raise your hand. Right. Otherwise, I would like to invite. Thank you, Niels. Thanks.
Invite Yorgos.
Hello, Bob. Hello, I'm Yorgos from NLNet Labs. For this hackathon, we wanted to start implementing DNS error reporting. Tom Carpay was in spirit with us because he did some preparatory work. We tried that. Happy Path seems to work. Testing for the Happy Path seems to work, but we still have more work to do, like some new introduced features in version 0.2. We need to make sure that the resolver doesn't kind of attack the authoritative name server. Yeah, more implementations to come. Any questions?
No? Okay. Thank you, Jorgos. Thank you, Niels. Yeah, so the Dnsop chairs think it's very important work, the IETF Hackathon results presenting also here, because it helps to make the draft, to make progress and give implementation feedback. So thanks again to the hackathon enthusiasts and the software developers. Next, we can get started. So can I invite the first speaker, Paul? Thank you.
I see. Right. Okay. Hi, I am a new deck being shared. Oh, no, I'm sorry. So I'm Paul Hoffman. I am the author of this document. They've given me 15 minutes to talk. I believe I'll take 5 unless there's a lot of questions. This has been on the list just pretty much since the last meeting. For those of you who haven't followed, it's a description of Dnsec. That's really all it is. It says, go look at these RFCs, these are required, you know, if you're implementing Dnsec. But one of the things that we really wanted to do was to have in a single place, if you want to refer to Dnsec as an RFC, a place to go. Next slide. That's fine. I put the 00 up, had some good discussion, had some suggestion on RFCs that I had missed. Oops. Put up the 01. Basically no discussion since then, and there are no open issues at this point that we know of. So it's not like we're in a rush to get to working group last call, but if there really are no issues, there's no reason not to sort of move it through. Again, it's not defining anything new. It is simply saying if you want to refer to Dnsec, this will be a single RFC to do it. And by the way, it's a BCP. We actually believe that it is a best current practice to use Dnsec. There was a little bit of an issue of, oh, well, I don't want to use Dnsec. You can always not do BCPs. In fact, lots of people don't do BCPs. But the DNS community believes that Dnsec is the best way to secure DNS messages at rest, authenticate them, and such like that. Next slide. Oh, I thought I had like a longer thing than that, just on the issues. I'm thinking of my other presentation, which will also go fast. So actually, we're at the last bullet. Is it ready for working group last calls? The chairs have just said that they're probably going to do that soon. Okay, so does anyone have any questions or want to say anything now? Again, it hasn't been in working group last call, so if you have a I wish this was changed and such, that's perfectly appropriate to do in working group last call. Does anyone have any issues? Less than 15 minutes. I'm going to use these stairs.
Yeah, the Dnsec BCP seems like a pretty straightforward thing to do. The document is short. If you haven't read it or you haven't read it lately, there shouldn't be. It seems like something that we should be able to move forward relatively quickly. So please speak up in the working group last call, particularly if you have issues, but also if you want us to move it ahead and to give us positive support for it. Thanks.
Hi, everyone. So as the previous presentation, I have been given a 15-minute slot. It's going to be much faster. So this draft has been around for a couple of months. Its recommendation for It's a recommendation for Dnsec resolvers operators. Next slide. So the goal is to describe operational recommendations to implement sufficient trust in that makes Dnsec validation accurate, and also to respond to many of the questions of people that are willing to deploy Dnsec, which includes ISP, but also other software vendors. The recommendations are described and include provisioning mechanisms, monitoring, management. And the good thing is that most of the recommendations are actually being implemented by some RFCs. So we just have to refer and explain why it is necessary. Next slide. So we have three kinds of recommendations. Those you need to do before you start the resolver, those you have to do when at runtime, I mean regularly in an automated way, and those are needed on demand. We spend a significant effort to say, don't try to mess up with the DNSec mechanics. So that was one of the key messages. And the topic we discussed are, of course, regarding time, how you manage the trust anchors, the negative trust anchors, keys that are not trust anchors, the cryptographic deprecations, reporting of invalid validation. Next slide. So we have received a significant amount of reviews. Most of them were needs or clarification. Up to what I know, we addressed them all. This is all documented into the GitHub, but we also review and rewrote the document to clarify this as a whole. So we expect the document is pretty well shaped to be sent to the next step. So if you have any comment, that would be really appreciate that you provide those during next month. Thank you.
Thank you, Daniel. So as Daniel stated, the working group chairs also think the document is, well, we want to make progress and it's ready for working group last call, but we definitely want to have people review this version. Thank you, of course, also for the previous reviews. No people in the queue? No? Okay. Thank you, Daniel, and we want to make progress and push the document forward. Thanks.
We are quite much today.
Yeah, we're good. We're doing good. Next up, yeah. Thanks. There we go.
Should I start?
Yeah, sorry?
Should I start?
Yeah, oh, sorry, yeah, please start. Yeah.
Cool. Hey all, I'm Siobhan, and Shumon, Paul, and I have been working on this new draft called, well, not new anymore, called Domain Verification Techniques. It was adopted, I think, yesterday. So eager to hear any feedback. Next slide. So just a quick intro. What is domain verification? What are we talking about? So many providers on the internet need folks to prove that they control a particular domain before you grant them some sort of privilege on that domain. So as an example, Let's Encrypt has a DNS-based challenge for a user to prove that they control a particular domain. It's called the Dns01. And if you can prove that, if you can add a particular record in a particular place, then you get the cert for that. Next slide. Yeah, so what the draft looks like right now is that it's a survey of the different techniques that different providers use. And then there's a recommendation section. But the draft is informational, so it's purely like kind of like a survey of existing techniques. So the two main techniques that we found were text and Cname. Next slide. So the text-based method basically says that please add this DNS text record with a random value, unguessable value, at the domain being verified, and that proves, because it's an unguessable value, that proves that you own the domain, and the service provider is able to check that. And it's supposed to expire in a few days, or the guidance around this is pretty vague and not very well documented often, and that's an issue. Like, people have had outages because of this. So there's wide variation, and part of the goal of the draft is to say that this is a good idea and this is something that you should be doing. Next slide. So just a few quick examples in the draft. A lot of these named examples where the feedback that we got on the list was that it's not a good idea to have them in the main doc. So we're thinking about just moving them to the appendix. For now, I just completely removed them, but I think it probably makes sense for them to be in the appendix. So this is an example where on a particular website like bbc.com, you might have a key value pair and the key says, okay, what is the company that is trying to do the domain verification? And the value is there's an unguessable value. Next slide. But you can also have something that Acme does and GitHub does. You have like an underscore prefix, underscore acme challenge.example.com if you're trying to verify example.com, and then the random value. And you can imagine that like this is, I guess the spoiler here is that this is a better technique in our opinion. But next slide. And you can also just have absolutely nothing. And then you just have a random value as a text record on the apex. Next slide. There's also the Cname based option, which is often touted as a fallback option. So different reasoning for why you might need this, but if you already have a Cname, then you can't really have another text record. So that's why you might want this. And this typically points to a service provider property. So then the provider can verify that, okay, actually this exists. Next slide. So this is another example where you have a random value dot the domain you're trying to verify, and then that is a Cname to something dot the company or the provider will check for the value. Next slide. Yeah, so I guess as I mentioned, it seems like it's best practice to target these records that you're adding to target them to a service, so that and the second one is that it's also good if they're time bound, and the guidance around that is pretty clear. Next slide. So yeah, so this is similar to what Acme and GitHub do. It allows the service provider to only get the records that they need, because in some cases, for example, when I was doing bbc.com from my home computer, it fell back to TCP, and because of just sheer number of text records, and my ISP at the time was just like drop the connection because it didn't support that. So the problem is bloating, and it's best if you can just query for the actual service that you're trying to get to. Next slide. And yeah, and time-bound checking. Like I have definitely been in a situation where someone removed one of these tokens, and then the service provider is like, oh, I guess you no longer own this, and shut off the access, and that's also not great. So there should be clear guidance around when can the record be removed, and arguably maybe you don't even need to for those records to exist in perpetuity. But yeah, in any case, there should be some clear guidance around that. Next slide. Yeah, and we got a bunch of feedback on the list. I think I've addressed most of that, but yeah, removed mention of specific companies, removed use of normative language. It's a purely informational draft, and also put a summary of the recommendations in the intro, and it was adopted by the working group. Next slide. But yeah, so there's one thing I need to do is, and there's a GitHub issue for this. I need to move the examples to appendix, and also, I guess, admin move to the working group GitHub. I think that's it. Yeah, happy to take any feedback, and or if folks think it should go in a certain direction. I think we've kind of like solidified on the structure, but happy to take any comments.
John O'Brien, University of Pennsylvania. Thanks for doing this work. Very helpful. And I'm also particularly glad to see commentary about the time limited, having things that are time limited. The other experience I've had, which you may wish to add to the document, you can tell me if you'd like me to put this on the mailing list or a GitHub issue, is I've come across some service providers who require either that the domain that's being validated is strictly a second level domain, for example, under .com or .edu, or in some cases that it's at a zone cut. And that causes some problems, especially in organizations such as mine.
Right. Thanks. I think we have an existing issue, but yeah, if not, then that sounds really helpful. Yeah.
Okay, John?
Yeah, John Levine. I mean, I like this. I like this draft, but honestly, I think if it's worth doing at all, it's worth doing as a BCP, because I think we can all agree that there are some ways to do this that are much worse than others. I mean, like not using putting the stuff with the name instead of a subdomain, not putting some sort of tag in the text strings so that you're not spoofed out by wildcards. And my guess is that there is not much disagreement about what's good and what's bad, and that seems to me it's a natural thing for BCP. Now, I would like to have a BCP I can point at that says, please don't do it that way. Here's concrete advice on how to do it and not screw other people up.
Yeah, yeah, that's something we have thought about. You can imagine that you could be more drastic and say that there should be a new RR type for something like this, but we didn't want to do that.
I think we had the RR type fight a decade ago, and I hope we can not have it again.
Yeah, I think so. The intention for this draft was to be a survey, but if folks think that it's better if it's a BCP, then very happy to hear comments on that. Actually,
thank you. We have a remote participant, Brett. Please go ahead.
Yeah, I mean, I've got exactly the same comments as John, really, basically. I think this is great work. It's good to see a survey being done, but I'd like to see, when the survey is done, I really support the next step of moving this into some kind of BCP to be able to point people at the right way to do it, and in particular to get rid of the bloat and get rid of the records that sit there forever. I think there are too many different ways to do this currently, and we should be trying to encourage people to cut them down. Thanks.
Thank you. And sorry, Anthony. Yeah.
Thanks, Anthony, Liquid. Yeah, good document. Not to sound like a broken record, definitely BCP. Just a comment on the TCP thing. I think definitely draw more attention to that, because as you pointed out with the whole retry, there's some quite critical records that sit in the apex, like your SPF records, and causing issues with email is not something that we want either. So it would be really good if we just draw attention to that as well.
Ben Schwartz. I like this draft. I think it should probably have one sentence about dname.
About what, sorry?
I think this draft should probably have one sentence about dname. I don't really care what it says, but it should say something.
Thank you. No other comments? Thank you for your feedback. Thank you, Sivan.
Yeah, if we have some time, I guess I'd be curious if folks think that we should just make this a BCP or whatever the chairs.
Yeah. Yeah, I think that's a good discussion, and I see Tim also nodding. Yeah, yeah. Okay.
I guess, does anyone object to?
So maybe, yeah, good question to the room.
Right.
Are there any objections for BCP? No? Okay, thank you. Yeah, we will talk with each other, with the chairs, and
Thanks.
adjust the status.
Thanks all.
Tim, you want to say something? Thank you. So next up is Yorgos Thessalonicus. All right. No, sorry. Not this one. This one. Yeah.
Hello again, I'm Yorgos, and together with Willem and Roy, we have an idea that we call dry run Dnsec. Next slide.
Sorry.
So how it all started, we got extended DNS errors, so the clients can understand what's happening with the resolution fails. That was nice. We're getting in the future,
Sorry.
Previous slide, yeah. We're getting in the future DNS error reporting. That is very nice. So zone operators know what the resolving errors for their clients are. And next slide. And then there was a random lunch discussion. That's all fine, but if I want to adopt Dnsec, that doesn't help me. The report is way too late. And then we thought DMARC. What DMARC does is, before you actually push the buttons and you apply a policy, you can just get reports and see what's happening. And then when you feel comfortable, you say, okay, let's go for it. Next slide. So what we're trying to do with dry run Dnsec is go from this is fine to next slide. This is fine. Actually, without fires and smoke. Next slide. So how it works, you sign the zone and you publish it in DNS, so everything is public. But instead of an actual DS record, you just put a dry run DS record in the parent. Then that gives a signal to the resolver that say, do validation, but this zone is dry run signed. So if something fails, generate a report back to the zone operator and fold back to non-dry run DS record. And by the way, validation succeeds, yeah, you can go ahead and give that 80 bit back. And you may have opportunistic security already, but with some caveats that I will address later on. Next slide. So a couple of use cases. First and foremost, we can have DNSSEC adoption. You can test your zone in the wild, and you can expect some reports back. If everything seems to work fine, then you can go ahead and push the button. So there's a turnkey action to deploy. Everything is signed and ready there in your zone, and then you just need to replace the dry run DS record with just a new DS record. No need to do any more changes. So what seemed to work previously with dry run DNSSEC should also work with the DS change. Next slide. You can experiment with DNSSEC. If your zone is already signed, you can do weird stuff with DNSSEC and then provide a dry run DS record, and the resolvers could tell you what's happening on their end. Next slide. And yeah, you can test key rollovers. This can work by using your real DS as a dry run DS, and then sign with a new key, introduce it as another dry run DS. You do your key rollover stuff. If the resolver finds an error, it will report to you, hopefully. And then if everything works, then you can do the same thing, but instead of the dry run DS things, you do the actual DS records. Next slide. You can also break it. You can use EDNS option so that the clients can signal the resolver and say, you know what, I know that you understand dry run DNSSEC. If there's an error, you will try to fall back, but you know, I opted in, so please just give me the error back. I want to be part of the test. So this can enable a couple of scenarios. You can get easier and faster debugging from the client side instead of waiting for the reports from the upstreams. And you can also use that in your application. So yeah, if I want to sign my zone, I want to see how the the application will behave if we get a Dnsec error. So this will turn like, next slide. This is fine. By the way, all these memes were already there for me to find, so people are weird. Next slide, please. So the details, we got some feedback on the previous IETF, mainly because what we propose as a dry run DS record is what most people, including us, at first perceived as a DS hack. And there were a couple of suggestions. Instead of doing a DS hack, we can use the flags in the DNS key. So they are now ignored, so you can use that space there. And although that seems nice, when you actually need to go from testing to actually signed, you would need to change the DNS key error set. And we believe that this is no good. So if you want to go from testing to actual deployment, it should be as simple as possible. You don't need to change the data. Another feedback was there are a lot of DS hacks, so maybe we can use a DS hack to rule them all. And we thought about it, but we now see that the dry run DS is more than a DS hack. If it's going to be adopted, we see it as an integral part of Dnsec, because it will give you the ability to actually test Dnsec. More feedback about DS hacks. So why don't we normalize all the different DS hacks with a range of error types on the parent side that they convey information about the delegation itself? Yes, we agree for that, but this is another draft. But by the way, this could work by having the dry run type as a new error type on the parent and then have the same DS data as the actual DS, but that is for another talk. Next slide, please. So what we currently have is two different timelines. The single timeline, which is the simpler one. So we have a specific dry run digest type, and then we push the 1 byte of the actual digest type as the first byte of the digest data. So this could work for resolvers that understand the dry run digest type, but it results in variable length digest. And we got some feedback that this may upset some people, especially the registries. So an open question to the room is, how bad is this? Can we live with a variable length digest? Can we change our tooling, or this is a no-go? Next time, please. And then there's the multiple timeline, where we introduce a dry run DS type for its DS, type, for its real DS type. Yeah, this will halve the space. We currently only have 4 assigned, and yeah, there's an open question to the room. Can we afford this, or this is too aggressive? Next slide. By the way, all signaling is backwards compatible. If the resolvers don't understand the digest type, then they just ignore it, so that's fine. Next slide. So provisioning, because you need to signal your parent that you want to do dry run Dnsec. If your parent accepts a DS, great, just give them the dry run DS. If they only accept DNS key because they want to generate the DS themselves, you need to either supply them with a DS because they need to see the dry run intent there, or maybe you do it through a UI and you need to check a box. CDS works the same. CDNS key, you need to have the accompanying CDS for that, so that you see that the child wants to do dry run. Next slide. So the security caveat that I was talking about is that if a zone goes from unsigned to signed, and then there is the intermediate step of dry run between, you can get opportunistic security, but if Dnsec fails, validation fails, then the resolver will fall back to insecure. So, and this is a feature, not a bug. So that means, yeah, if you get the ADB, that's fine, but if you don't, you can take, you can't get any results from that. So, for example, because they were talking about Dane, that won't work. Next slide, please. We started implementing the NSR reporting, which this draft relies on. we are in the early stages, but when we're done, this could be a next step for us for Unbound. Next slide. That was it. So I would like to see what people have to say about it and maybe provide some answers.
Thank you, Jorgos. Wes?
All right, thank you. Thank you. I really like the idea. I think it's a great idea. You know, it's worked well in mail. It's worked well. You know, I think your comparison to DMARC was spot on. With one caveat though, which is that anything you introduce in this had better not disrupt any validation behavior, you know, in regular Dnsec. So to me, that immediately rules out any sort of DS hacks and immediately rules out, you know, algorithms and things like that as a mechanism for doing that, because we already have cases where DS algorithms provide funky things when one is unknown. So if it's a completely separate record, either somebody will understand, a validator will understand it, or they won't. And if they do understand it, then everything's fine. If they don't, or even if they do, the validation chain has to be totally the same for the actual answer.
Yeah, I agree.
Thank you. Remote participant, Steve, please go ahead.
Thank you. I'm not sure I understood completely, but when I saw going insecure, I start twitching. I don't like going insecure at all.
Sorry, can you repeat that?
Yes, as I say, I'm not sure I've completely understood the totality of what you were presenting, but at the point where you said if something fails, you go insecure, that raises a red flag for me. I don't like the idea of going insecure.
You don't like the idea of going insecure?
Right.
That's what you said.
Yeah.
That's what I said, yes.
But so for that use case, you're starting from an insecure zone, right? And then you try to sign it, and if everything validates, it's going to be secure, or it will fall back to insecure. But dry run Dnsec is not meant to be a secure final state. So getting the insecure answers back is, at least from my point of view, fine, because you're still testing.
You're saying it only arises when you're starting from an insecure state, from an unsigned state. It doesn't arise when you're in the middle of, say, changing the signature.
No. Sorry, I didn't get that.
Does this
Yes.
is this used when you are rolling the key?
So, so if you want to test key rollover, so that means that your zone is signed, and then you want to test if rolling a key would work. So this would start in the dry run, let's call it the dry run DNSSEC part of the zone. And if anything fails there, the resolver should fall back to the actual DS zone. So
okay,
the previous state, yeah.
Okay. So as long as it doesn't introduce a period of going insecure from a secure state, then I'm okay.
Yeah. I want to clarify that if there is an error in the dry run state, you go back to the previous. It's going to be insecure for an insecure zone, and it's going to be secure for a secure zone.
Thank you.
Thanks.
Victor Duchovny, Google. My concern is that, okay, the mic is low, sorry about that. Warren's fault. My concern is that you seem to assume that all the resolvers out there, in fact, behave as specified and will do the right thing when presented with an unknown code point. Just 2 days ago, I tried that with algorithm 0 and was deeply disappointed from at least one major resolver. I think all such assertions, unfortunately, need extensive field testing to determine whether that's true or false. And I'm also concerned about considerable implementation complexity in an already fairly complex stack. So I don't know how much adoption such a thing is likely to see from major providers, where you really want good coverage for this thing to be effective, right? If they just treat the new code point as unsigned, no real testing happens until you actually go signed. So you'd need the Cloudflares and the Googles and the Binds, everybody to really adopt this before it's particularly useful. So it's a pretty tall hill to climb. I don't know how we get there.
We did some preliminary measurements from the previous ITF, although it was RIPE Atlas measurements. So we used unknown digest types. The results looked pretty good, but still it was just RIPE Atlas. So yeah, you can't be 100% certain.
Okay, Paul?
Sorry, Paul Hoffman, can you go back about 3 slides to the single track?
Yep. 3 slides.
I guess that was, are you able to? Yes. To one that he had single track and dual track, and I wanted a comment on the on double track.
Signal timeline, yeah.
Then now it's
More back, more.
2 timeline.
Yeah.
The one before this. I'm sorry, this
No,
one.
this
Sorry,
one.
this
Yeah.
one. Yep.
Okay. Yeah. This one.
I think even though some folks might not like the variable length because it's hard for them, blah, 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 just as Victor said, things that are not implemented well are going to have a hard time regardless. I think this is absolutely a feature for us testing new DS types where, in fact, the digest length is going to be surprising, such as for post-quantum crypto. So I think if we, which fortunately is way in the future, although way can mean a lot of things to different people, if we have this with a variable length digest type defined before we start futzing with the post-quantum algorithms and some of the things that go along with that, we will absolutely get much better data about, how things are going to break. So I would strongly recommend going to this with a variable length digest type.
Thank you.
Ben Schwartz. Thinking about this I'd like this functionality. I think this would, if somehow we lived in the future that Victor outlined, where all of this had eventually rolled out, this would be a very useful thing for use cases I've run into. One thing that I would like if I were using this is to be able to answer the question, what is the error rate of what is the error rate that you've created by adding this? And I don't think this proposal actually gets me there, right? I get error reports, but I don't have a denominator. I don't know what fraction of my recipients actually implement the specification. So I don't know the error rate that I'm generating. So I think maybe a more flexible system that could do things like request a certain number of positive confirmations to say, yes, it actually is working. That would be helpful.
So I can comment on that because this draft relies on DNS error reporting, and the new version has support for a no error flag. So as an upstream, you can signal to your resolvers to say, okay, you see me, but please send me back a no error so that I know you're there. Because if I don't get any error reports, how should I know that everything is okay, right? So you get a thumbs up if nothing is wrong from your resolver, and then maybe you can also use that information for what you described.
Okay, and would that actually work for this? Because knowing that the resolver supports the DNS error reporting is not sufficient, right? I need to know, the denominator has to be the fraction of responses that went to resolvers that implement that and also this.
Yeah, what you would see is that, okay, X amount of resolvers contacted back with no error, so I know they're there, and then I start getting errors.
Okay.
It's not the actual number that you want, but it is something more than just getting the errors back.
Okay, thank you.
Yeah.
Hi,
Hi, Lars Lima from NetNode. This is a good thing. You mentioned that this is viewed as a temporary measure for transition between states, and I totally agree to that. In order to avoid having lingering stuff in the system that may or may not interfere further down the line, would it be an idea to either put some kind of timer into the system that kicks out this functionality after a certain time, or to have a recommendation to implementers to put timers in the software that interacts with this, just to avoid, as the same thing with the records for domain authentication. We don't want lingering, rotting stuff in our DNS. Just an idea.
Yeah, but with timers, you mean how long the dry run state is going to be?
Yes.
Right?
Yes.
But this is easy because it's about the DS record. So it's a manual intervention. You can either turn it on or off.
Yes.
I mean, if you leave it there, you're just going to be on dry run Dnsec forever.
Yes,
I mean,
and we don't want that.
yeah, but if you want to transition, you need to manually do it. There's
Yes.
no automatic transition for either state.
There were-
Or you just you leave the DS record expire on the keys. But yeah, that's garbage. That's what you're saying.
What I would like to see is to have it removed after a certain time, unless someone manually kicked it to say, yes, now we are in running state.
Yeah, I don't know how to do that automatically, but I understand what you're saying. Yeah.
At the risk of making my good friend Steve angry with me, I actually think this would help if you were going from secure to a new algorithm role to insecure. I mean, I wrote a draft a while ago about that sort of got 50% support for people liking it and 50% that absolutely hated it. This might help in that case, right? If I could point them to it saying, if algorithm roles are tough, try doing this. I will say that I think there's a lot of corner cases that you need to work very carefully through, like a DDS pointing to the same key versus a DDS pointing to a new key, and how many RR-SIGs must be in the file when you're doing all of this testing, and the zone suddenly grows and you're returning a lot of extra large packets and things. So do make sure you work through all of the weird corner cases and then start talking to the registries very early about having a new DS record inserted, DDS record.
Hi, it's Peter from Dsec, Peter Thomason. So a few things regarding the cleanup of stale dry run records. I would think the only entity that may feel that it's harmful for those to stick around will be the corresponding registry or parent authority. And I think it's not a problem for the registrant or somebody else. So I would make that local policy for the registry, right? I mean, they can write in their documents that we will remove your dry run record after 4 weeks or whatever. They feel like that, and then .de is going to do that perhaps, and some other registry going to do some different thing. I think that's okay. Maybe perhaps a minimum should be specified.
Or you can use the TTL of the dry run DS record for that.
Well, perhaps that's a bit too short because.
So I mean, you can put a huge value there, but then, yeah, okay.
Yeah, for example.
Yeah.
Anyway, I think it's mostly a local policy issue. The second thing regarding the digest field length being variable, I think it is better to sacrifice a bit of the digest type field. And I also don't think that with post-quantum crypto, it would be necessary to expect that the digest field length will vary, because even when the key length varies, the SHA hash is still just a SHA hash. And then last thing I wanted to say, maybe to point out as an implementation note in the draft. So far, if my understanding is correct, although I don't know exactly the provisions in the Dnsec specification, is that when you do validation of a chain and you encounter DS records, essentially you need to find one that matches and then you start processing. And it's not necessary to keep scanning and matching other things. And it's up to the resolver, whatever digest type they would consider suitable for matching. Now, if a resolver does have support for ignoring validation failures when there is the dry run bit set, and even they would send out DNS error reporting stuff in that case. That they may not be hitting that code path if they earlier are encountering a DS record that does validate and then they stop processing. So I can imagine that a naive implementation of support for this could run into this problem. And perhaps the draft should point out that you need to continue scanning the other DS records to actually run this kind of experiment.
So we haven't implemented anything yet, but the way of thinking was when you encounter the DSR set, pick one of it. So one dry run, one real one, the ones that you would have picked normally, and then try the dry run. And then if that fails, see if you have a non-dry run and try again.
Okay, fair enough, I guess.
But this is without an implementation, just an initial idea.
Yeah, implement just need to be aware that it's not permissible to stop after the first match if you want to support this. That's all.
Yeah.
Sam Weiler, we have a proposed standard RFC on how to do Dnsec experiments. Sure, we have a proposed standard RFC for how to do Dnsec experiments that says to use the algorithm number, not the DS record. I'm not convinced that we need to pop up this level and do it here. If the working group is, we should probably be updating 4955. However, I'm really concerned about what I just heard, which was about changing the validation rules and maybe only looking at one of them preferentially. That you start to go down a real slippery slope there. And I like 4955. I think it's probably sufficient.
Okay.
Niels Vizio, Dsec. Sorry for being late to the game. I just wanted to float the idea of sending DS records with eDNS client to the resolver instead of propagating all this information to the parent zone. I believe I'm not a resolver implementer, but I believe that could keep down the complexity. So this is a reply to Victor's comment about complexity. So if the client just sends DS records for testing along with the query, the resolver could validate against that rather than look in the parent zone.
But you mean the client itself provides the resolver with a DS record?
Yes. So you assign your zone, and then you want to test it. So what you do is you query, let's say, Google public DNS, but you also include the DS records that you want to propagate to the parent zone. And then the resolver would validate against that and give you the result. So you don't need to talk to the parent registry.
That would work for the opt-in case, right? So the client is opting in for testing. Yeah.
Yes. Yeah.
Okay. But this will not work for on the wild, let's see what's happening on random people.
Right, but how would you get the results from testing in the wild anyways?
Through the parent with a dry run DS. Okay. No, I mean, what you described works perfectly, but only for the case that the clients are opted in, right?
Yes.
You can test random people on the network.
Right.
Yeah, okay, yeah.
Couple of comments. I'm not sure that client-side DS signaling is viable because cached data has already been validated. It's rather unclear how this would work with results already in the cache. In terms of where to put the dry run bit and the variable int digest type and so on, I do agree that stealing a bit from the hash algorithm number is saner than moving the digest type into the digest value. Hash algorithms are introduced exceedingly rarely. Symmetric hashes are very stable. There's no evidence that SHA-2 is likely to be compromised anytime in the next 100 years. We're doing very well with that one. We may add SHA-3 at some point, though there's little demand. Steal some space from the hash algorithm if this is to go forward. That seems to be the way to do it.
If I can comment on the casting, because that's a good point. We thought about it, and we'll need to keep both Dnsec states in the cast because clients may need to get the error, may need to get the non-error response. Yeah.
Mark Andrews. As for variable length digests, we're going to need them anyway for private OID and private DNS key algorithm types. So don't be scared of that. In terms of a replacement for CDNS key, I think you should be looking at doing another key, another type, which signals that's a similar semantics to CDNS key, but signals that you're wanting a dry run DS be produced. And in terms of experiments, who was it? Doesn't matter. Earlier, it really doesn't matter for experiments. For experiments, as long as you don't have both values that are known, you got a new value in either of those two fields in the DS record. That's perfect. You make you have a safe experiment. So, okay. That makes sense?
Kind of, yeah.
Thank you. Thank you for all the feedback. And thank you, Yorgos.
Thanks.
Yeah. Next up is Paul Hoffman.
Hi, I'm also still a new deck being shared. So now we're in the space where things have not been adopted by the working group. So this is a request for people to consider adopting a draft, even though this is a BIS draft of something that we finished not that long ago. 8109 is just a few years ago. It's on a topic that a lot of people find really, really boring, but it's on a topic that happens all the fricking time. So it's sort of important that we tell people how to get this right, which is DNS priming. Next slide. So 8109 is out. We believe it's well implemented because it doesn't really say much to do other than the very basic thing that has been talked about in the DNS really since 1034, 1035, which is when you have a completely empty cache and you get your first query, the way you prime is that you do this and then this and then this. So 8109 didn't change that. It helped resolver operators understand better sort of some of the I wouldn't even call them edge cases, but interesting considerations of that. And yet still we see some resolvers that don't necessarily always do it the way that would be best for its users. And since it is so important to get priming right, getting it wrong affects a lot of people pretty much silently, which is really bad. So as this working group was working on what became 8109, some issues came up and people said, we just want to get 8109 published. That's a controversial issue or whatever, and we punted on them, which is fine. But now with the fullness of time, we can actually take them up again. And also, since we brought it up, some new issues have arisen. Next slide. So this is a large list, and by the way, this is my second to last slide. I'm not going to go through all of these, but I wanted to point out, if you read the draft, you will see this list in the draft. These are things that we've already looked at. So the reason why I put up sort of, it's not as bad of a wall of text as some other people's, but is that we've already seen a bunch for 8109, a bunch of issues that, so it's more than one or two issues is what I'm trying to say. We think that it is worth opening this up again, even if we punt on some of the issues, there are plenty of other things in here that are more or less important to more or fewer people. Some of it's just terminology. The root server operators have a very specific way that they want to be referred to. I think it would be good for us to do that. This working group loves the TC bit at the same time that it hates the TC bit. We want to deal with that more and such like that. But we think that it is worthwhile, even though it's not the most interesting subject, to actually get this nailed down. And so this would be a BIS. It would actually obsolete 8109. And again, if you find any of these interesting, please look in the current draft to see where it is. Next slide. So this is what's not yet in the draft. Prefetching has become a much more popular topic in the last few years. And certainly for the root zone, many people would say prefetching would be a good thing. So we should be talking about it. There's nothing we can say you should, you shouldn't, but we shouldn't pretend it doesn't happen. And then there's also the question of post-priming strategies. So after you've primed, after you have this set of NS records, thank you, after you have this set of NS records, everyone knows that different resolvers do different things to pick which is their favorite authoritative server for any zone, not much less the root zone. But some resolver software actually treats the root zone as special. We can say don't do that as often as we want, but they do. And so there should actually be a discussion of, once you've got the zone sitting there, how do you pick which authoritative server to use? Do you pick the fastest? Do you pick the one underneath this thing? So these are all things that we know, that people have talked about. We don't need to say you should do this or that, but we should certainly admit that, in fact, there are these post-priming considerations, particularly for people who are watching things on the wire. It is completely believable that a resolver comes up, does a priming query, goes to qroot, reboots, does a priming query, and then goes to rroot instead. You know, like within the course of 15 seconds, for whatever reason. Normally, we would think, oh, it'll always go to the fastest. We know that that's not the case. qroot and rroot might be approximately as fast. There may have been a route switch, things like that. This should be discussed in 8109 is our belief. So I think that's the last slide. Oh, and then I guess the obligatory last slide is, does the working group want to adopt it? We don't need to talk about that now. There's no rush, but I also think that there's no reason to wait for it. It's not like we're expecting any new news going on. So that was it.
Thank you. Any questions, comments from the room?
Excellent.
No? Okay.
Thank you.
Thank you. Thank you very much, Paul. Okay, that closes the for consideration section of the agenda, and now we're up to the time permitting. So a remote presentation by Dan Wing. I think you want to run your own slides.
If you could share them, that would be great.
Yep.
Thanks. So I'm Dan. This is basically now an extension to EDE, which was nice to see some progress on earlier. Next slide. So the purpose for this is, when there is DNS filtering, to provide more information about what was filtered and by whom, so that can be tracked down if that filtering was...
Sorry, Dan, you moved the microphone maybe? We can't hear you, or difficult to hear you.
I had some papers next to it. My apologies. Is that any better?
Thank you.
Sorry about that.
Very good.
Next slide. So the changes we made between 01, which was the last time that I presented on this, to the current version is further constraining the JSON and when it's displayed to the user. And the reason is there is concern that the browsers would be unwilling to display information that was controlled by the DNS resolver that the browser is talking with, and instead just throw that into a log that IT or a more sophisticated user can look at, but not have it be something that's popped up straight in front of the user's face. And also to help constrain those messages, instead of having the free-form text that we had previously, the second bullet talks about sub-error numeric codes that we introduced in this version. So for example, what's defined right now, 1 is for, it was filtered because of malware, 2 for phishing, 3 for spams, numbers like that. And then also to ensure that we don't have a cache poisoning problem is to require the ADD resolver info to signal that there is support for this and that the information returned in there is actually from that first hop resolver and not being sent down from something else and causing the EDE to get propagated. And the next slide, please, shows an example what the JSON is that's being sent, and that's currently being sent in the EDE text field. So instead of sending, human parsable text, it's got kind of human parsable JSON. And that's my update. Next slide, please. And I'm wondering if there's any further interest in this. There seems to be, and would certainly like any comments from the room or from the 108 other people.
Thank you. There's one question from the room. John?
John O'Brien, University of Pennsylvania. I'm curious if you've looked at whether this could interoperate usefully with response policy zones. And if not, that seems like it would be a valuable addition.
Okay, thanks.
Peter, please. Mic is yours.
Hello once again. Can you hear me now?
Yes.
Yes, excellent.
Good. I like the changes and I hope that the browser vendors will like them as well. Do you have any feedback from either Google people or Firefox people, how they think about the latest changes? Because that was the main issue last time, right?
Right, that was the main issue. Tiro has received some positive feedback. I forgot from whom, I'm sorry. But it seems more amenable to browsers, especially getting rid of the freeform text and going to error code numbers so that then the browser can localize the message and also especially not display the freeform text that we had previously. That seemed to resolve most of the issues that we'd been getting feedback on for those. But unfortunately, Turo is asleep right now, so I don't know who those specific folks were, unfortunately. Sorry. I'll get him to follow up with you, Peter.
Thank you. Brett, also remote participant.
I just want to add my support to adoption of this and also agree with the previous guy who mentioned supporting of RPZ. This would be really useful operationally for us for our protective DNS resolver that we operate in the UK.
Cool, thank you.
Ben Schwartz. I do think that this revision is an improvement. I still wonder. I wonder a few things. I wonder if Dnsop is really well placed to deal with this. I think that this is really getting to a much deeper and thornier question of how malware type filtering ought to work in a user device setting. The major browsers today already have functionality of their own here in the context of things like safe browsing. And those systems aren't simple query response systems in the way that the DNS is, for example. Instead, they tend to use complicated quasi-private information retrieval algorithms to avoid revealing private user information. We can sort of stuff this kind of functionality into the DNS, but should we?
Okay. Thank you. Well, Tim wants to respond to that.
sorry, I made this comment in the chat, but the chairs are interested in this, but we'd like to hear from folks who are actually going to be implementing this, because that will actually help us drive, the sort of if the working group sort of takes this on as well. So if folks are interested in implementing, please speak up and give us some heads up, and that'll help us a lot. Thanks.
Yeah, indeed. So outside the Dnsop working group, we did hear from other people that were interested in the draft and also probably interested in implementing. But we would like to hear that also in the working group. And maybe, we will plan a call with Dan and the chairs how to go forward and get more, support or explicit support of and implementation, potential implementations.
That's fair. Okay.
Yeah.
Awesome. Thank you.
Thank you. Oh, sorry, we still have two. Oh, I hope Dan is still online. There's still two questions here. Jonathan.
Yeah, I was just giving another +1. I support adoption of this. I can't personally commit to Akamai implementing this, but I could see it being very feasible for us to implement for our services that we offer that provide filtered responses. And I think, Ben's question about is Dnsop right is a fair one. I do feel like every time there's a real world problem that operators are coming and saying this is an issue, the question comes up of, is this the right working group? And my question is, if not this one, which one, right? Because I think, this is a problem for operators, and I think we are empowered to address this, and this is the right place for this.
Cool. Thank you.
Thank you.
Victor de Governay. My comment is mostly actually back to Ben, I think. I don't think this is a new mechanism to implement virus scanning that isn't of any sort. This is really to deal with reporting existing RPZ feeds and their classification of a domain. It's already blocked. We're just adding transparency as to why, so that the user can be told why the DNS name isn't resolving. So I don't think it's in conflict with any more sophisticated or active filtering that the browser is doing with the content at hand. It's really reporting DNS resolution that's going to happen one way or the other and telling the user why.
Okay, thank you. Thank you. Chris?
Hi, Chris Box, BT. As a customer of Power DNS, I would like to see this developed and we would deploy it in the network.
Okay. Thank you.
Thanks,
John?
It just occurs to me that since the web or the internet hasn't been completely overtaken by HTTP, that this would be useful for applications other than web browsers that can't present a captive portal and might still like to be able to propagate up exception information of this kind to a log or some sort of user.
Cool. Thank you.
Thank you. Okay. Thank you all. Thank you, Dan. Up next
Thanks for the
is
time.
Becker. Okay. Thank you. I will.
Hi. Well, I'll have slides in a second. Right. So I'm here to speak about some research that's trying to answer a longstanding open question about DNSSec on the internet. This is joint work with Austin Hensel and Nick Feimster from Princeton and Chris Wood from Cloudflare. Next slide, please. So here, this is not my work. This is work by Nick, I guess Jeff Houston probably, measuring the extent of DNSSec validation on the internet. So as you can see, there's quite a bit that, this line's a little hard to follow, but something on the order of 40% total validation rates. So that's seems like good news. Except next slide. Basically, all that validation is done by recursive resolvers, not by endpoints. In fact, some of the data suggests is largely Google Public DNS and people Cloudflare and people like that. So no major operating system will do endpoint Dnsec validation by default. Apple just rolled this out, but I checked with Tommy Pauly, and you have to turn it on for yourself. And browsers won't do it either. And this is obviously super limiting. And if you want to roll out any feature that requires like Dnsec and requires not trusting the recursive resolver, like Dane, then you need endpoint validation. By the way, this talk is like entirely about like endpoints, like consumer endpoints. This doesn't apply to like server machines, server class machines. I know there's quite a bit of Dnsec validation for like send mail and stuff like that, for mail and stuff like that. It's not what I'm talking about here. Next slide. So as a browser manufacturer, I often get asked, why don't you jerks validate? So I've produced a set of answers for this. One answer people often give, and there was is concerns about performance, namely that you have to do more requests, and maybe some of them will fail, or maybe you have some trouble doing them in parallel, so maybe it'll be slower. But the primary reason, the one highlighted in bold here, is we're concerned about breakage. So what happens if you have some sort of middle box, whether it's your recursive resolver or proxy, whatever, that doesn't deliver the DNSSEC records or mangles them in some way? This is indistinguishable from an attack. What you know is there was like a DS record, and you know things should have been signed, but congratulations, they're not, or at least you can't validate it. And what you're supposed to do, according to the RFCs at this point, is to hard fail, is to refuse to accept the data you've been sent. But like when you're looking up an A record, if I respond to that by hard fail, then what my user sees is they're trying to go to a site and they can't get there. And the general sense among people who actually build this stuff is that any significant rate of non-delivery, like in excess of like fractions of a percent, will create unacceptable failure rates. What I mean by that is that if we roll out some new piece of functionality in the client and we see an increase in failure rates that is like in excess of a fraction of a percent, it's unacceptable and we have to back out. There's really been very little data about this. There's some work by my team a few years ago, along with some people at UCSD. There was a thing about maybe 10 years ago by Adam Langley, where they tried to retrieve random text records from the internet and like had like 5% failure rates. So 5% would be way excessive. And so Adam has this like famous post that we often refer to about why people don't do this, and it like refers to this experiment. But like that's not DNSSEC, it's text records, and it's a long time ago. So we decided to try to answer this question. Next slide, please. So this is a very straightforward experimental setup. We set up some domains that we control ourselves. They have valid records, one trusts, because we can set them up. Actually, Cloudflare set them up with their automatic, signing. So we have correct DNSSEC records, RR-SIGs, DS, DNS key, whatever. We also have some other less common records, which I'll get to in a minute, like HTTPS Service B, SMIME, some new records we made up. And we use Firefox as a measurement platform. So what we do is we randomly select a subsample of Firefox clients, and then each client tries to directly resolve the relevant records. We do use the system resolver, which I'll talk about in a second, but not for this. So for this, we do like a UDP, we look up the operating system's resolver, and then we talk to it directly with UDP or TCP, and we ask it for records, and we see what the answers are. And we measure the success rate. Next slide. So here are the queries we do. And we do some of these in a random order and some of them not. We start with using the Firefox DNS Resolve API, which just talks to the system resolver. And this is just to verify like everything's working. Because if we can't get this, then like things aren't going to work. It also gives us a control baseline of what like a failure rate ought to look like. Then we ask for NSA randomly. We ask for A records with all possible values of DO and CD. I sent some people here may remember I sent mail to the mailing list asking what to set these values to. So we set them all, just to be sure. We try DNS key. We ask for service B. We ask for SMIME, and we ask for 4 records with all combinations of small and large and code points and expert review and private use ranges. And all these, as I say, are like correctly populated, so they should all succeed. So here's the next slide. This is with the actual answer to this question. So red here is just DNSSEC. So the baseline failure rate, and I'm sorry, I did lose DNS Resolve, so that's unfortunate. The baseline failure rate is about 2%, which is like a little surprisingly high, actually. DNS Resolve is about 1%, a little less. So there's some extra, something quite right with our resolvable that's causing like a little diff there, we're not sure about. But if you look, as soon as we start asking, and so this failure rates are we getting the correct answers? There's a combination of do we get like nothing, and do we get like the thing doesn't match? And so as you can see, if we just do the straight up, are these all off by 1? These may all off by 1, which is really embarrassing. The bottom line straight up answer is that, oh, right, I see what's going on. Okay, sorry. So the bottom line straight up answer is that if as soon as we try to ask for RSA, we don't get it. We don't get it like a third of the time. So, and like we like looked at this 8 ways from Sunday, we looked at the things by hand, and like a lot of them are too small, so they couldn't possibly have an RSA, and they don't have truncations yet. It's just like, don't come. If you have CD equals 1, of course, you don't get it at all, which is expected. But if you do DO, you don't get it, basically, right? DNS key you get, so that's fine, but you don't get RSA, basically. You don't, and then these other records, it kind of works sometimes. So like if you ask for SMIMA, you get it like 15% of the time, sorry, 85% of the time. Ask for HTTPS, you get it like 93% of the time. And these other records kind of work sometimes, but not reliably. And the bigger the record, the worse it is. It doesn't seem to matter whether it's in private use or whether it's in non-private use. So this is like what we see. I'd be happy to talk to people offline about or online about the methodology here. But this is basically what we see here. We don't, by the way, we don't, we did actually ask, this is all with UDP, TCP is a disaster, like he's got like a 20% failure rate across the board. If you, just to apply a little more color, we did try asking for RSA separately, that also doesn't work very well, by the way. It's not even clear that should work. We didn't, as an admission, we didn't ask for DS, but obviously if we don't have RSA, this won't work, so it doesn't matter. Next slide. So, like, what's the impact of this? Bottom line here, it's not safe to enable endpoint Dnsec validation over DO53 for like generic endpoint clients. It's fine, probably not fine for server class machines, but it's not fine for client class machines. It might well be safe to enable them over DO or DOT. We did sort of experimentally measure the public resolvers, and they seem to do just fine. So if you like, if you ask like 1.1.1.1 or 888, like they do a fine job of giving you these answers. It might be the case that ADD advertising resolvers do better, but of course, we don't really know yet because that doesn't really exist, but like you might imagine anything's been updated does a better job. The security posture on that is a little confusing. It's somewhat practical to deploy other record types. So if you have a new record type where it's like, if it worked 80% of the time, that'd be great, like HTTPS, then like that really is fine. But if you have something where it needs to work all the time, like basically it's not safe to do anything that isn't basically like A and Cname. And I guess NS. There seems to be some variation, like HTTPS looks especially good. It may just be because it's smaller than SMIMA, we're not sure. So anyway, this is the bottom line for us. We have a paper that we've written that we're not quite ready to like publish, but we'll be publishing pretty soon. It has more details of methodology. I'm happy to answer, of course, any questions about this that people have.
Thank you.
Oh, can you go back one slide? I'm sorry.
So,
can you back one slide?
Yeah, one
more thing. As I was looking at this, I realized what happened. The sorting algorithm is wrong. The system resolver is on the bottom. It's just 0.4% is the failure of the system resolver.
Yeah, hi Eric, Ray Bellis, ISC. Sorry, do I understand correctly these experiments done within a Firefox browser on end user sites?
Yes.
Okay. My own research now, which was like 10 years old, showed that home gateway resolvers are particularly bad at this side of things. So I'd very strongly suggest you try and maybe enumerate whether the resolver you're talking to is on the same subnet as the client, so that you can actually tell the difference in the stats between on-net resolvers and off-net resolvers.
That's a good suggestion. I think we can do that, but I'm not sure.
Yeah, I'd take a look at RC5625 and the SAC. Try to remember the number now.
If you'd be so good as to email it to me, because I'm never going to remember those numbers. But yes, it is very similar. Of course, it's very difficult for us. We can talk in detail about whether we could actually exploit that information, but for experimental purposes, that's a great idea.
Okay. Brian Dixon, go ahead.
So sort of echoing Ray's train of thought. Do you have the ability, or would you be able to do longitudinal per end user collection of information to see for a particular browser, is the failure rate consistent, and are you able to track that across network changes? And can you potentially aggregate those to these customers always failed, and therefore you could check initially, and if you get failures, not do the validation, but for any of the ones that do succeed, if the longitudinal collection of data suggests that if it succeeds, it'll always succeed. That information I think would be very useful.
Yeah, I mean, so in principle, the answer to like, can we take that measurement is yes. In practice, the answer is that the grad student who did this work has taken a job, and so probably the answer is no. If I manage to find somebody else who's willing to do the heavy lifting, then the answer is probably yes again.
Hazel?
Hi, obviously, firstly, thank you for doing this. One question I had is, you mentioned, I think, on slide 8, possibly, that you had done some testing of dot and do resolvers to see how they behaved. I was wondering whether you had done enough of that to collect any data, whether you had any graphs for that.
Sorry, could you say the last sentence again?
You said about do and dot resolvers that contacting them with DO and CD set was more successful. Did you get enough data to produce any kind of useful statistics on that? Do you have any charts, graphs, anything like that to sort of like to be able to draw that's viable?
Yeah, no, what we did was basically, we only realized that this was an interesting question at the very end. And so we just like connected from like one of our machines to like those nut resolvers and check that they did it correctly. And our assumption is that because Do protects the data in transit, or dot does, we don't have to worry about whatever intermediates there are. So the view from anywhere is as good as the view from anywhere else. So we assume that like if Cloudflare or Google does it correctly once, they'll do it correctly indefinitely. So I don't think there's much data on that, but I'm not too worried about that part of it.
Sure. I guess I mostly meant from the perspective, as I think one of the previous questioners mentioned, that potentially the issue wasn't necessarily the resolver that you're talking to, but the middle boxes in the way, or sort of CPE equipment at home environments, whether something was mangling the traffic on the way there and back. And like, I mean, obviously you'd hope that.
Right, but Do and dot will bypass all those mechanisms. So we assume it'll be cool.
Yeah, it would just be nice to see numbers, but yeah, I take it.
Yeah,
if you haven't got them, you don't have them. Yeah.
They wouldn't have it.
Thanks.
Victor Duchovny, Google. Thanks for doing this. It's good to see these things updated again, and it would be good to see it in the future after some time. It's often we end up quoting things that are 5 to 10 years old. So excellent, thank you. I was curious whether you've anonymized the sources to a degree that might make it difficult to break this down by GeoIP or AS numbers or whatever. It would be nice to see how the situation varies across the globe.
Yeah, we do have that data. That's in some of that's in the paper. But from memory, it is substantially US and Europe are like substantially similar. North America and Europe are substantially similar, and China and India are substantially worse. And especially worse for like the non-standard things. But that data is in the paper, and I think we have it by, if I recall, ISP and AS. So like if there are other analyses people that are interesting, we could probably run them.
Mark Andrews, did you do a plain EDNS query? No flag bit set beyond them.
If I recall, I can like check this for you. But if I recall, we always set the EDNS max record size for all the queries. And like, and that's one of the reasons we think it may be worse for the baseline query. I can share the code for like doing this is in a Firefox extension. So so I can share that with you.
Yeah. Home CPE devices are notoriously bad at everything.
Sorry, can you get closer, because I'm hearing a lot of stuff from there.
Home CPE devices are notoriously bad at doing DNS properly.
Yeah, exactly. I mean, I think so. I mean, our assumption is this is like largely broken home devices. But of course, we have to go to like war with the home devices we have, basically.
Daniel Kahn-Gilmore, thanks for doing this work and thanks for publishing it. So one thing is just that it would be nice to see the breakdown of failure rates by actual size of the packets.
We have that.
Okay. And then because the size does seem like it's a likely failure.
Yeah. So I mean, we don't have like a linear, we don't have like a linear, but yeah, we could give you a scatter plot basically. I think, but I assume you mean the size of the expected packet as opposed to the size of received packet.
Yeah, though I'd be interested in both.
Because we have that too. I mean, it's like basically when we saw like like all data analysis has errors, right? But when I first started looking at this, I was like shocked at how high the rates were. And so I spent some time like, are we really, I just like our parser screwed up, right? And so like I went and looked, like binned out how big things were. And in a lot of cases, things are way too, like, too small to contain the record. And that's what persuaded me these days is substantively correct. So yeah, so we have all the information. Let me see what I can do to add that to the paper.
Yeah, that would be super useful. And then the second thing is just this observation that, you know, the network is filled with garbage, and you're helping to demonstrate that here. And I think we as the community who's thinking about how we evolve the network need to think about what we do about that, right? We can't remove all of the CPE equipment, but if we're writing the software that's running on the client, we can say, if your local network has these kind of failures, then we will do something else. And I think it's worth looking at this and saying, hey, encrypted transports are both more privacy preserving and more capable, and we should start ignoring the garbage parts of the network to do that. I just think, you know, we should send that signal as clear as possible.
You will be taking my support calls, right?
So Wes Hardiker, RFC 8027 actually is the Dnsec roadblock avoidance document that talks about this type of stuff and talks about, you know, it would have been neat if you had the chart of like how many resolvers fell into the different categories, because one of the things we did is outline tests for all the things you need to do, you know, to get a Dnsec compliant sort of resolver in front of you, and to know when you don't, so that you can make appropriate decisions, or at least know when you're being, you know, attacked in some way. But one of the things that we talk about in that document is, you know, if you don't have one, then you can fall back to doing it yourself. That's of course more ugly, and you don't get caching benefits and all that other kind of stuff. But it would be interesting to do that analysis. And then finally, I'll note that your table is missing one important record that you should have queried for.
Which is DS?
RRSig.
Oh,
because you actually can do that.
So okay, so like I am now about to like way over my skis. We do have that data.
Okay.
We took it out of the table because the failure rate was astoundingly high. And then we found an RFC whose number I cannot remember, which led us to conclude that the RFC query was not supposed to work. And I can find a link for you, and then you can explain why I'm wrong.
No, I don't care whether it's supposed to or not. I will say that the IETF resolvers do allow it to work.
Yeah, and so you know, we came to the conclusion that the IETF thought that wasn't supposed to work.
Sure.
And so if I'm wrong, like we have the data, we'll put it right back in. The one we're actually missing is DS, and we just forgot is basically the answer.
All right, well, thank you for doing the work, because it is interestingly and depressing to look at. So.
Thank you. Yeah,
just
very short comment.
Yeah, very short comment. Yes, RRSig isn't really supposed to work.
Okay, great, thank you.
Thank
so people have my email address. If you want to talk more about this and you have questions, you know, please reach out to me. If you think I've screwed something up and like this is egregiously wrong, please tell me. I'd rather I know now than otherwise. And if you think there's some other things like maybe I could get out of this data that would help you, please let me know. But thank you for listening. I appreciate it.
Yeah, and thank you for sharing this. Okay, thank you. So we come to the last agenda item. Peter Thomassen, please come.
All right. Hi, it's Peter Thomassen from Ds-Tech. So it seems like I'm getting 11 minutes to talk about my 2.5 slides. But perhaps it'll be quicker. So you all, I guess, know RFC 7344, which is CDNS key records for announcing your DS parameters in the child zone. And the parent can query that stuff and then, for example, use it for rolling over DS records when you do, let's say, key change, or also for onboarding Dnsec for a zone. And while working with this in the context of bootstrapping Dnsec, I encountered, let's say, an interesting situation that I wanted to point out, and I think it needs correction in the RFC. Specifically, the RFC 7344 doesn't specify how the parent should be doing their poll queries to retrieve the CDS records from the child. And that can cause a problem if the CDS or CDNS key record set turn out inconsistent across authoritative name servers for a given zone. So let's say, I don't know, I'm the .de registry, for example. I'm querying CDS records for Peter Thomassen.de, and then what to do if that's different on one name server and on another name server. You can say whatever, it's endorsed by the DNS operator, so who cares? It'll be right one way or the other, and it isn't sorry, and if it isn't, it's going to be the fault of the DNS operator, but that is not entirely true in multi-homing setups where I think this is specifically a severe problem, because it may lead to one provider in a multi-signer setup to be able to unilaterally roll the DS record set with intention or without intention. I think, for example, a typical problem could be that there is multi-homing, let's say at NS1 and Cloudflare, for example. Both of them do signing, announce each other's keys, and there's going to be automation for this and RFC drafts going on and all of that. So that's going to be more common in the future, perhaps. And let's say now one of the providers rolls a key and publishes new CDS records, and at that point forgets to publish the other operator's CDS records. And then the parent comes, queries that, ends up only retrieving one part of it, essentially rolling the DS record set, and then the zone is broken, the delegation is broken because the keys of the other provider are going to be missing. And that's like a problem if it occurs, but also conceptually, a single provider shouldn't be in the position to be able to remove another provider's trust anchors. So I think this needs correction. And this is the first of 2 slides. And the second slide, which we're going to now, has the proposed solution. So I think it would be nice to have a short document that clarifies that if you're querying as a parent these records from the child, you need to query them across all of the name servers and may only act upon them if they are consistent. So the proposed wording here, which is in the draft I uploaded, it's an individual draft. It says that the parental agent who knows the child zone name and the NS host names authoritatively, because they are the parent, must ascertain that queries are made against all of the name servers listed in the delegation and ensure that the set of reference keys is equal. And then in other words, when a CDS or CDNS record set is returned by one name server but not referenced in the corresponding answers of another, then that situation must be considered inconsistent. And if such inconsistency occurs, then the parent must take no action, specifically not delete or alter the existing DS record set. So I'm happy to discuss what people think about this, and if you think it's a good idea, perhaps we can work towards advancing this some way.
Thank you. Mark.
Let's see. You've got one case, you've got a denial of service attack if you require.
Can you come a bit closer? I have a hard time hearing.
Mark Andrews, you've got a potential denial of service attack if you require every NS to return the same DS records. All you need is a machine that's down and you can't correct. You can't recover from that using a rollover. And in reality, DS records are no different to any other RO type. If your DNS, if you're multi-homed and one of them does something to the zone, DS records aren't really any different to any other record type that can potentially be served. What's the difference? You've got a trust issue here. You've got to trust the operators that are signing the zone for you. When you've got a multi-signer, when you're running multi-signer. So I really don't see the need for this.
Okay, so my opinion on this is that, of course, it's just records like any other, and if you serve 2 different A records, that's fine. The proposal is not imposing any restrictions on how to publish CDS records. You may publish inconsistent CDS records if you like. The proposal is an instruction to the parent whether to act in a situation that is known to be inconsistent. And I think the first time this goes wrong for a large domain, we better want that provision.
I think my concern, this is Victor Hovny, Google, my concern is similar to Mark's. There are probably, I think, not uncommon hidden masters that are listed in the NS record to facilitate various kinds of internal synchronizations, but aren't necessarily exposed to the outside world. Such domains won't necessarily be able to be reached at every name server. Whether it's a good idea to list dead name servers or not is a separate question, but I would expect it's not entirely uncommon. And also, of course, if the only name server with the private key, it fails, and you need to do an emergency roll and tolerate the outage, whatever, then again, you can be stuck, as Mark indicated. So requiring every single one sounds a little risky. This needs some thought.
Okay, I think that's a fair point. So perhaps the wording could be amended so that it's fine if a name server does not return any CDS or CDNS key records with a proof of non-existence, of course, but those that do, I believe, should be consistent, because otherwise, how do we address the concern that one provider is accidentally screwing it up?
Ben Schwartz, it looks to me like there's a missing time constant here.
A missing what?
Time constant. Because normally the TTL, I guess, tells the parent how often it needs to recheck the CDS. But if you checked and the answer is that the CDS is in an inconsistent state, when do I recheck? How often do I repeat this check?
So in the current specification, the CDS TTL does not impose any schedule on the rechecking. It's completely up to the parent what to do, and I believe there is no registry. I mean, there's a bunch who implement the scanning, I think 7 or 8, but I think they all do it daily, regardless of TTL. So yes, it could be done through the TTL, but I think it isn't.
Okay, that's interesting, but even given that, I don't think that we would want the result of this to be, well, we'll try again tomorrow. If you're trying to execute a transition like this, an additional 20, checking once every 24 hours, it could be a very long time before you get you get into the right state again. So I think you might consider, putting in some time constants, recommending that you check back in 5 minutes to see if, in case you happen to be right in the middle of a transition.
Do you mean checking every, whatever, 5 minutes, for example, in the case you encounter such inconsistency, or do you mean in
Right.
general to quickly catch CDS updates?
No, I mean specifically in
Okay.
the case of inconsistency.
Okay, I understand.
Okay. Thank you. Thank you, Peter, for the feedback from the audience. Yeah, I think we're done. We're
Thank you.
perfect in time. We completed the agenda, including time permitted. I would like to thank the presenters for presenting their drafts and their work. And I also would like to thank the participants in the room for constructive discussions and feedback. We see each other either at the next interim in September or in November in London in person. Any other final words, Suzanne?
For those in the room, it's great to see you in real life. And for those out in the remote, wherever you are, thank you also for being here. And I guess that's a wrap. Thanks, guys.